Now, I took that same chart with the x's and y's, so these are the actual x's and these are the actual y's, okay? That's what I got going on here, x's and y's. Those are the ordered pairs that I make a scatter plot out of. But look what I added there. I added a y hat, so I actually put each one of these x's into the equation and did the math, and I got all these y's. Okay, so these are all of my y hats. Those are all of my y hats. Now, then I went one step further, and I subtracted the y hats from the y's, and I got the residuals. So this is every residual. There's some positive, there's some negative, because some points are above the line and some points are below the line. Okay, so this is the residual plot. This is a new thing for you guys today. It's the residual plot, and it's used to decide if a line was a good idea for the data. So if it's a residual plot, here's what's going on. These are the original x's, and these are the residuals. That's how I make the scatter plot, L1 and the residuals. So here's the line y equals 0. So I'm just going to kind of draw a horizontal line and say that's y equals 0. And notice there are positives and there are negatives. That happens because the line goes right through all the dots. Okay, so the horizontal axis is seconds, which is x, or that would be our L1, of course. And the vertical axis is residuals. That is y minus y hat. Okay, and then I'm pointing out, like, what are we doing all this for? Why would I even care about this? Okay, a residual plot is used, let me say it again before I write this down, to tell whether the line was a good idea. Maybe it should have been a curve, not a line. Let me go back to the first page here for a second and look at that scatter plot. Maybe it should have been kind of a curve instead of a line. That's what we're doing, is why we use the word assessing. We're assessing whether that line was a good idea. Okay, so here's how you actually use a residual plot. You're not going to have to make one for homework. You're going to see one and you're going to make a decision. That's your job. So since scatter plots, I'm so tired. Since scatter plots tend to scatter, that's what they do, the least squares regression line should sneak right through the middle of all the points. That's what it should do. So if a line is actually a good fit, there should be points above the least squares regression line, and there should be points below the regression line. But more importantly, furthermore, there shouldn't be any pattern to the residual plot. I shouldn't see a pattern in the numbers. So this is it. This is what you needed to learn today about residual plots. I've got two more things for you to learn, but this is the big moment for the residual plots. If you get a homework problem, it gives you a residual plot and it shows uniform scatter. The line was a good fit. If it shows a curved pattern, the line was a bad fit. Okay? So don't write this in your notes. Can you see the bottom of this page? Let me move it up a little bit. Don't write this in your notes, okay? Here, I'm gonna make a clearly curved scatter plot. You can tell that's curved. And then I'm gonna draw a line that goes right through the middle, and I'm gonna kind of make a residual plot. Hopefully you can follow along with this. Using these same x's, this one was below the line, this one was above the line, and then below, above, below, above, below. You can kind of see how this looks curved. There's a pattern to it, not like this one where there isn't a pattern. So if I'm looking at this residual plot, I'm thinking, yep, the line was a good idea. If I'm looking at this one down here and I'm seeing what looks like a curve, my answer to the question would be the line was a bad fit for the data. That's how we use a residual plot right there. Next page.